Okay, geometry. We are in Chapter 10, Section 3 today, talking about composite figures. Very fun. So try the warm-up, come back and check your work. So the area here is simply equal to base times height, right? Very good. Triangle area equals BH over 2. Good. And trapezoid, A equals B1 plus B2 times H over 2. So there you go. I'm sure you had no problem there. Today's objectives are to use the area addition postulate to find the area of composite figures and to use composite figures to estimate the areas of irregular shapes. So we have this term composite figures. And so what do you think of when you think of composite? Combination, right? A composite figure is made up of simple shapes, such as triangles, rectangles, trapezoids, and circles. To find the area of a composite figure, find the areas of the simple shapes, and then use the area addition postulate. So here we have a really fun area. We have, you could call this a, trapezoid with a half circle. Some people might see this as a rectangle with a triangle and a half circle, right? So we're going to find the shaded area and round it to the tenths. So chop the figure into parts, right? What do you think is the best way to look at this given the information provided? Yeah, probably a trapezoid with a half circle, right? So we make a plan. We're going to, I like making the big plan. You know how that is from 7th grade. And the big plan here would be, let's grab something here, right, with area total would equal the area of the trapezoid, right? I don't know if I can find a subscript here. I don't see one, so let me just do it this way. I'll just put in parentheses, whoops, the trapezoid, short for trap, and plus we're going to have the area of the circle, right? Okay, and it's a half circle, so I guess we can make a note of that. I'll say 0.5 of the circle, right? So that's the big plan, and the key here jumps straight into finding the area of a half circle. Which area of a circle equals? Good, pi r squared, so this would be pi r squared over 2, or 1/2 of pi r squared. What is the radius? Good, 10, so we have 10 squared. 10 squared is 100, and we could take half of 100, right? And they call that 50 pies. And then we could multiply 50 times pi, and remember, round at the very end, right? So it looks like they're finding the area of a triangle. Interesting. And so they have found the base of the triangle, given 20, 32, take away 20, gives you a base of 12 and a height of 14, so half of that is 84. So then they're finding the area of the rectangle, so they were doing it a little different than I had proposed, right? But the rectangle then would be 20 by 14, and they found that to be 280. These are all millimeters squared, right? And so once they have all of the pieces, combine them and multiply by your pi, right? And rounding it, we have a total combined composite area of 521.1 millimeters squared. Okay, find the shaded area. How are you going to view this composite? Are you going to find a parallelogram? Are you going to find a trapezoid, triangles? So make a plan. Please make an overall plan, and then find the areas that you're looking for, combining them to give you the complete area. So if we look at this figure here, it is a beautiful parallelogram, right? And we're given the height. So that is what is in the plan here for this composite figure. We have a big parallelogram that is 8 by 5, and then we have this triangle which has a base of 10 and a height of 5. So when we put it together in that way, we have the parallelogram at 40 feet squared, and then we have area of the triangle, which I guess would be, what, 25 feet squared? Combining these together, we have 65 feet squared. Very good. So go ahead and find this shaded area. Notice that we're not using addition, we're using subtraction this time. Make a big plan and find the shaded area. Okay, hopefully your plan was to find the area total by finding the area of the triangle, right? Oops, that should be a parentheses back there. And we would then subtract, right? Subtract the area of the half circle. 0.5 circle, half circle. So hopefully you did that. If you haven't, stop now and go do it, right? Okay, so the area of the triangle, we don't have, or actually we do. We have a base and a height that are perpendicular here. 18 by 26, right? Half of 18 times 26 is 234 feet squared. And then we have pi times, what is the radius? 4.5. Pi times 4.5 squared over 2, or half of pi times 4.5 squared. And okay, so they did find that 4.5 squared, we don't see the squaring here, but is 20.25, and then taking half of it, they got 10.125. There it is. And pi, right, in terms of pi. Now we're going to finish this by combining the two, and that is taking the entire triangle and subtracting 10.125 pi, and they end up with an area of 202.2 feet squared. I hope you're having as much fun as I am. These are fun. I love these donut problems. We have a big circle donut, and we cut out what shape? A trapezoid. So I hope you're starting with that big plan. The total area, let's put this over. The total area equals the area of a circle. And in this case, we're going to cut out the area of a trap, right? Trapezoid. So good. And if you haven't done it, pause, come back. If you have done it, we're ready to look at this. The area of the circle, don't forget the radius here is half of the total diameter, right? And we have the area of the trapezoid, very fun. And we're going to subtract this from the area of the circle, and rounding to the nearest tenth, we have 186.2 centimeters squared. Excellent. Let's do it again. Another donut type problem, right? So we have a plan. And what is our plan? Total area equals the area of what shape? Circle, right? And we're going to subtract the area of what shape? Looks like a definite rhombus, right? Looks like 90-degree angles as well. Let's call it a rhombus just to be more interesting, since that's what we know. And there you go. Make your plan and go find your answer to the nearest tenth. Okay, so you, I'm sure, started probably with the area of the circle, right? Which was a radius of 3. So we have 9 pi, or 28.3. Now, how are you going to find this, the sides here? And yep, we're going to use the Pythagorean, right? And so we end up with 4.24 squared, or 18 inches squared. So subtract that from your circle area and we have 10.3 inches square. The lawn that Katie is replacing requires 79 gallons of water per square foot per year. How much water will Katie save by planting a xeriscape garden? A garden that doesn't require that kind of water. You know, this is funny because I don't really think that we know how much water is going into the xeriscape garden, so I don't think we can really answer this. So not a good question. We could find the number of gallons of water that are used for this garden in a year, right? So find the square foot area, and the square foot area would simply be, you know, addition of these pieces, right? And so the pieces end up becoming 375.75 square feet, right? Multiply that by the number of gallons per square foot, and this is the total. But they haven't told us how much we're saving. There must be some water requirement for the xeriscape, so let's move on. If you have an irregular shape, I mean, it's not a polygon, we've got these curvy areas, almost an amoeba looking kind of thing, we can estimate the area by treating it as a composite figure. So first we would draw a composite figure that kind of resembles the irregular shape, and then divide that figure into simple shapes. Here's an example of that. Let's estimate this irregular shape. So the grid has been superimposed over this strange looking shape, and so the grid is going to be an aid to us in trying to find figures that we recognize, figures that would be similar to what we see here. So let's kind of walk through the plan that the book, the editors came up with. It's kind of not very nice looking. Let me back up. And let's do this one more time. We're going to grab this image if we can. And why it's putting a line right down the center. Okay, and we're going to grab that image. I'm going to cut it out and take it to their little plan here. So I'm going to go ahead and stick it over here. So here is what we're working with, and here is the plan. Down here we could say we have what appears to be, what shape is this close to? So a triangle, right? We have a little triangle. We might say that the base and height are 1. I think that's what they're showing us here in this second piece here. A base and height of 1 here. So let's call that part 2. Well, let's name that part 2 here. We have an area of a triangle. Part 1 is an area of a triangle that has a base of 2 and a height of 1. So I believe that's right here. It looks like part 1, right? I would say that this looks like part 2. Now when we stretch this across, this almost looks like a rectangle, doesn't it? They have a rectangle here of 2 times 1, which pretty much looks like this piece here. Oh, I see they're calling it C, so we can name it C, right? C is here. The area of the trapezoid D is a trapezoid with a 2 by 1. So could it be this here, 2 by 1? I think it is. So we'll call this area D. Hope you understand my numbering. And so 2 by 1. And then, did they include this piece here? They have a 2 by 1. This isn't quite 2 by 1, so maybe a little piece of this is included here. And also this is not quite 1 by 1, so I think this is shared between 1 and 2. So they're adding these figures together that are the composite of this entire strange figure, and the shaded area is about 5 feet squared. See if you can estimate this shaded area here. Actually, not estimate, but find exactly, because this is a composite figure you can find. And for number 2 as well, come back when you're done. And I hope you have found that this pencil is about 38.6 centimeters squared, and this figure number 2 is 50 feet squared. Please finish number 2 and 3 and come back and check. 3 and 4. 3 is 6480, and 4 is